Hey guys, I want to show you a project I've been working on with Raspberry Pi and Arduino. The goal of this project was to create log data for a device used in a solar power plant. I created this Java application to run on a Raspberry Pi. The Raspberry Pi is able to log the data as well as display it. The program is geared to start on boot up, and it's taking data that's being emulated from an Arduino Uno, which is emulating the state of charge unit on the solar panel. So some of the big things I'm working on was getting this program to launch on startup. So I could show you how it does that. So this program launches on startup. While that's booting up, I'll show you some other things I've been working on. This is the Raspberry Pi. For development purposes, I use two chips, or two SD cards, which are the Raspberry Pi's hard drives. I use a development chip, which contains Eclipse and an Arduino programmer. Had a lot of problems running Java programs on a Pi because they're just a lot slower for some reason. Has to do with the CPU being an ARM processor rather than an Intel. So I had some problems with null pointers when the Java program wouldn't load fast enough. The only way for me to debug those issues was actually to develop code directly on the Pi using the dev chip. Well, okay, here's the Raspberry Pi. It's booting up now. As you can see in the bottom right, you can see the CPU usage. Something's loading. And there it is. So the state of charge reader loads. It automatically connects to the Arduino, which is on, the text is kind of scrunched up. It's on dev/ttys0, the COM port. The Raspberry Pi automatically disables the serial port, so I had to get around that by writing a script to rename the port on startup, and that script also launches this application, the logging thing. So every time the Raspberry Pi is restarted, the serial port gets renamed to something that's usable, and the logging process starts. And yeah, that's about it. So there's the Pi, the entire computer. If you're curious about what that antenna is on the right, in the future I hope to be able to log GPS data, and that's a GPS antenna. Or I may use a cell phone, integrated cell phone chip. I know those are kind of expensive. I think I spec'd one out at $1,300. But yeah, that's in the future, depending on what type of funding I have for this project. I think I've reached my cap today, probably well over it. But yep, there it is. As you can see, the data is being updated every time the TX button, that's 1 time per second, transmits data to the Pi, gets interpreted by my program and logged. I'll show you where the logs are. As you can see, this program is relatively high CPU usage. I would say about 20% of the CPU is being used, just because it's a big file. So here's the log files. I might want to put them in a directory, but that's another programming issue. So here's a sample of it. A big part of this was appending the time data. The unit doesn't have time, so the first is the data, time data, what time that was read at. That's 2:32. Raspberry Pi does not have a built-in clock, so another thing we had to do was integrate a real-time clock in the Raspberry Pi. So there's a lot of things that this project entailed. Okay, well, if you guys got any questions, feel free to send me an email. And that's about all I got for you guys today. Thank you.